A very, very good morning to you and a very warm welcome to Pages Exam Prep IS. Come on, guys. Very good morning. Shri Hari. Good morning, Yuvashri. Good morning, Saurabh. Good morning, Vechri. Good morning, Anjali. Good morning, Dhara, Dhwani, Purva. Very good morning, Nagaraja. Hello, Deepika. A very good morning to you as well. Good morning, Sunil. Acha, hello. Watch 12th fail. Lovely. Did you like it? Good morning, Vanshika. Good morning, Akula. Good morning, Daneshwar. Good morning, Roshan. Good morning, Saurabh. I'm fine, Saurabh. Just pulling along. How are you doing? Good morning, Vanshika. Very good morning, Stephen. Absolutely. All right. Great. Great. Hello. Okay. So, good morning, Tagdis. Good morning, Devyani. Good morning, Saradya. Oh, it's pretty pleasant here, Dhani, actually. 20 kindish. Good morning, Nancy. Good morning, Smita. Good morning, Akash. Good morning, Amala. Good morning, Anurag. All right, come on, guys, hurry up. Good morning, Ankur. Good morning, good morning. Come on, be fast. Great. Good morning, Sadhana. Good morning, Dikshit. Ajo, come on, guys, hurry up. Good morning, Neha. All right, guys. Now let us start. I hope that others join soon because the concept that I'm going to take up, if they join late, then they will be saying, sir, please repeat. All right, I think we're done. Elon Musk joined. Oh, great. I'm popular. Lovely. All right, sir. So let's begin. So as it is, we are done with these portions. The left-hand side has been attended to completely. We're doing syllogism today after we complete calendars because that has also been done partially. So is clocks, so is ranking, cubes and cuboids we will take tomorrow along with logical connectives and puzzles. All right. Elon Musk is going to be acquired by Beju's. All right. That's a real lol. Lovely. Good morning, Govind. Good morning, Shubhangi. Okay. Now, guys, yesterday we had left one topic. Okay. What particular portion of calendars. All right. And that is to find out the day of the week on any given day. Whatever may be the day given to you. Okay. Now, here, this is how you're supposed to approach. First, I need you to know that after a century year, let us say after 1900, the first leap year occurs in 1904, then 1908, then 1912, then 1916, and so on. So that is every 4 years, you get a leap year, correct? And I'm talking about non-century years. And you know that in non-century years, every 4 years is a leap year. That is clear to us, right? Good morning, Abhishek. Good morning, Ritika. Just please be fast. All right. So now here, what you got to find out is, let us say, find out the number of odd days in given number of years, right? First, 42 years, all right? And I'm talking about only non-century years, right? Okay, let us say 1900 onwards. All right, so 1900 to, let us say, 1942, or 1901 to 1942, whichever way, you have 42 years with you. Okay. Now, in these, yesterday's type 2 of calendar not explained and few PYQs. Abhishek, that's exactly what I'm doing here. All right. So, in 42 years, how many leap years will be there? See, in 42 years, there are going to be some non leap years and there are going to be some leap years. Correct? So, how many leap years will be there in 42 years? Well, number of leap years is 42 divided by 4. Okay, 10 is a 40. So, there are going to be 10 leap years. Out of 42, 10 are leap years. So, remaining 32 are non leap years. Now, you know that in a non leap year, you have one odd day, and in a leap year, you have two odd days. All right, so total number of odd days here happen to be 32 plus 20, that is 52 odd days. Correct? Obviously, 52 is a number which is greater than 7. So we will further divide this by 7, goes by 49. So ultimately, you get 3 odd days. Now, my point here is very simple. What you can do here is, why don't we directly add the leap years to number of years? See, you still get the same thing. Number of leap years here are 10. If I add 10 to 42, all right, still I get 52. Okay. Assume that all 42 years are non-leap years. Assume there is no leap year. Assume that each and every 42 years, each year out of 42 years is a non-leap year. So what do you get? You get 42 odd days. All right. But just now, maybe, someone told you, Array, there are 10 leap years in these 42. And you know that a leap year has 1 day extra than a non-leap year. So 10 days more. So as it is for 42 years, we are going to get, as it is for 42 years, we are going to get 42 odd days plus 10 leap years should give us in total 52 odd days. So what we are supposed to do? Directly add the number of leap years to the given number of years. So what do I get is 42 plus 42 by 4 leap years. That's it. 42 years plus 42 by 4. So this is 42 plus 10 leap years. So now I should get a 52 odd days. So directly you can do that. Obviously, the answer to which is again going to be 3 odd days. So how do you find out number of odd days in given number of years? How do you find out the number of odd days in given number of years? Well, number of years plus number of years divided by 4. Wait, not now, not now. Doubts we will take later. Doubts, not doubts, extra questions that you have, you post them to me. All right, let me just complete this. Okay, not in the class, please. Now you tell me how many odd days are there? How many odd days are there in, let us say, 47 years? How many odd days are there in 47 years? Palak, just look at this. This is how you find out the number of odd days. Yes, Srihari, this is only for non-century years. Number of odd days for 47 years will be 47 plus 47 by 4. Okay, so this is 47 plus another 11 leap years, right? So that gives you a 58 odd days. 58 you will now divide by 7, so goes by 56. So you should get 2 odd days. Is this clear? Lovely. Yes, you got this. You got this. Okay. Now tell me how many number of odd days, do you have in, let us say, 81 years? 81 years. Come on, hurry up. Years plus years by 4. Years plus years by 4. Perfect. All right. So this is going to be 81 years plus 81 by 4. Okay. So that is 81 plus, I can say 20 leap years, right? 4 into 20 is 80. Okay. So we have 101 odd days. Now 101 again is a figure which is greater than 7. So divided by 7 goes by 7. So 31 goes by 28. So we must get 3 odd days. Perfect. Perfect. You got this. You got this. You got this. Lovely. So one more. One more. Okay. So how many odd days are there in, let us say, 27 years? How many odd days are there in 27 years? Look everywhere. Year plus year by 4. Year plus year by 4. Okay. So what do we have? 27 plus 27 by 4. So that should become 27 plus 6 leap years. 4 6 are 24. All right. So hence we have in total 33 odd days. 33 when we divide by, 33 when we divide by 7, because 33 is a number greater than 7. Odd days are always less than 7. Goes by 28. So we should get 5 odd days. Yes, you got this. Lovely. So everyone is clear on this aspect. Let me just check once. Come on, guys. Now, do you know how to find out the number of odd days in given number of years? Number of odd days in given number of years. It is 6 leap years, sir. It is not 624. 27 by 4. All right. 93%. Lovely. Now, this is where I am. Now, you remember that century years, 100, 200, 300, 400 were there. All right. And I told you that 100th year is a non-leap year. 200th year is a non-leap year. 300th year is a non-leap year. All right. And 400th year is a leap year. All right. So the number of odd days in these years, let us say in first 100 years, there were 5 odd days. All right. So 200 years, there are 3 odd days. 300, 1 odd days. 400, 0 odd days. How did you get this? How did you get this? Well, 100 into 2 is 200. So 5 into 2 is 10, which again, when divided by 7, should give you 3 odd days. That is why. Similarly, 100 into 3 is 300. So 5 into 3 is 15, which again, when divided by 7, gives you 1 odd day. So 1 hair. All right. Now, 100 into 4 is 400. So 5 into 4 is 20, plus 1 more odd day, because 400th year was a leap year. 400th year was a leap year. All right. So in total, 21 divided by 7 gives you 0 odd days. So immediately, all right, I want you people to remember this 5310. Can you remember this for me, please? 5310. What are these? These are number of odd days for 100, 200, 300 and 400 years. $300 is divisible by 4, then why it is not a leap year? Say, Khushbu, where are you? Huh? Yesterday you attended the class or not? Huh? A century year is a leap year if it is divisible by 400. 300 is divisible by 400? No. Huh? So in centuries, it is only 400, 800, 1200, 1600 and 2000 which are leap years. Other centuries are non-leap years. Remember? Good morning, Samar. Why century year 100 has 5 odd days? All right. So how many odd days are there in 100 years? In the first 100 years I'm talking about. First 100. So you have 100 years plus 104. All right. Now look at this. Look at this. Look at this. These many leap years should be there. So it is 100 plus 25 leap years. Correct? But can I get 25 leap years here? Huh? We know that 100th year is a non-leap year. All right. So correction here shall be, it is 100 years plus 24 leap years, because 100th year was not a leap year, it was a non-leap year. Remember, I just told you, we discussed this yesterday also, no? So that gives me a 124. So we get 124 odd days, which when divided by 7, all right, gives me 5 as the remainder. There you go. Get it? Now, Jia? All right. So all I want you people to do right now in your notebooks, 100, 200, 300, 400, 5310. These are the number of odd days. 5310, 5310, 5310. If you want to remember it, memorize it in Hindi. 5310, 5310, 5310, 5310, 5310. Is it done? Anshu, there is no previous question. The number of the number of odd days, if you have to find out in years. See, if you're joining late, that's bad. So in given number of years, let us say we have, I have already shown it here actually everywhere. So you can go through it. Like in 81 years, if you need to find out the number of odd days, okay. So it is nothing but it is years plus years by 4. Okay. Okay, no place here. So I'll write it here. Number of odd days in a given number of years is nothing but number of years plus years divided by 4. These are leap years. Okay. So how do you find out leap years? Just divided by 4. So as it is, this is the formula we have used everywhere. So in 42 years, how many odd days? 42 plus 42 by 4. In 47 years, how many odd days? 47 plus 47 by 4. In 81 years, how many odd days? 81 plus 81 by 4. 27 years, how many odd days? 27 plus 27 by 4. All right. Now look here. Sam. It is going to be the same for a cycle of 400 years. So 100 years has 5, 200 has 3, 300 has 1 odd day, 400 has 0 odd day. Now similarly, 500 years, 600 years, 700 years, 800 years, 900, 1000, all right, 1100, 1200. So 1300, 1400, 1500, 1600, 1700, 1800, 1900, 2000. See, 800, 400, 800 to 1200, 600, 1600, 2000. All right, these are all leap years, right? And others are non-leap years. Now, clear, Sam? How it comes 6? See, I want you to be a little fast, Anshu. This will become very difficult otherwise. What is the sixth question? Which question are you talking about? I have not discussed question number 6. How to come a 6, sir, in 3 questions, sir? Question number 3, where is question number 3? Where is 6? This is question number 3. Where is 6? Can you please hurry up? Where do you see a 6? Anshu. Shri, specify where is 24. I have to search for the whole sheet. How do I remember where is 24? Ask your doubt specifically. Please hurry up. In 4. So question number 4, have I written 24 anywhere? Please tell me, guys. Yes, Anshu. How did I get 6? Arey yaar, 27 divided by 4. 4 6 are 24. So 6. 27 by 4. Come on, Anshu, please. Yes, Shri. In century years. In century years, where did I write 24? Here. All right. See, did you read this, Shri? 100th year is not a leap year. So we will not get 25 leap years. All right. Remember, 96 will be a leap year, but 100 will not be a leap year because it is a non-leap year, non-leap year, non-leap year, non-leap year. 100th year is a non-leap year. It is not a leap year. So when you divide 100 by 4, you get 25. But actually, we don't get 25 leap years. We get 24 leap years in first 100 years. Okay. So here we can say in the first 100 years, there were only 24 leap years. Okay. Why? Because 100th year was a non-leap year. Clear? Deep, why are we getting 49? Arey yaar, this is not done. All right. 100 into 2 I have written. No. In 100 years, you are getting how many? 5. So in 200 years, 5 into 2, 10. Why should I consider 49? What are you talking? All right. So let's go forward. No, it is only for century years. It is only for century years. Divyani, very evidently, what is 100, 200, 300, 400? Century years, na beta. Then why are you thinking of any other year? Get it? Shri, you watch the video again. If you are not able to understand that, just please remember this. 5310, period. Okay. Because see, these are irrelevant questions. What you are asking is if it's non-leap year, we should substitute 1. What is this? Or sub 1. How do I understand your language? Sub 1. All right, let's move ahead. Now, listen to me carefully. How do you find out the weekday? How do you find out the weekday of any date which is given to you? Weekday of any date which is given to you. Okay. So the question here is, which day of the week fell on 15th August 1947? Which day of the week fell on 15th August 1947? Like this. Now listen to me carefully. Listen to me carefully. All right. First step is, whatever year is given to you, you will divide this by 400 because you need to find out the nearest multiple of 400. Okay. Why? Because in 1600 years, which is a multiple of 400 and near to 1947, in 1600 years, the number of odd days will be 0 because 1600 was what? 1600 was a leap year. All right. So we shall break this 1947 in this way that you will get 1600 and then in centuries, whatever centuries remain. So plus 300. Okay, because if you divide this, you get 347, divide this by 100, you're getting 300 here, 1600 here. So can I write 1900 as 1600 plus 300? Very much. But why am I writing it as 1600 plus 300? Because we need to find out that century. We need to find out that century which was a leap year. And which centuries are leap years? Which centuries are leap years? 400, 800, 1200, 1600, 2000. All right. These are those centuries which were leap years, or more specifically, century years which were leap years, right? Only these 5 were leap years. So whatever date is given to you, you see what is the year, all right? And you write first that multiple of 400, which is just near to that year. So 1600 is near to 1947. Then if you have any centuries in between, or let us say you write the nearest century year. Now to 1947, nearest century year is 1900. To 1947, the nearest century year is 1900. Clear or not? Okay. And 1900 can be split into 1600 plus 300. Why 1600 plus 300? Is first you find that century which was a leap year. All right. So in 1900, if I am taking 1900 years, up to 1600 years, I know that the odd days were, the odd days were 0. Up to 1600 years, and in 1600th year, the odd day were 0. All right. Now you remember this 300. So remember I made you write this 100, 200, 300, 400. Number of odd days is what? 5310. So in 300 years, there were 1 odd day. Okay. So if there is some other date which is given to me, let us say 1986. So which is the nearest century? 1900. Okay. How will you split it? 1600 plus 300. If you are given a number, let us say 1429, this was the year. Okay. So you see which is the nearest century? 1400. How will you split it? 1200 plus 200. Get this now? 1200 was leap year. See, out of these 4. Okay. So if you are given, let us say, 948th year, how will you write 948th year? Well, it is 800. First of all, you will write it as, let us say, 800 plus 100. All right. Likewise, because 800th year is a leap year. So 400, 800, 1200, 1600, 2000. Out of these, 1 year will come here. All right. So when we are talking about 1947, nearest century is 1900, and the nearest multiple of 400 to 1900 is 1600. So first is 1600, then 300. So 1900 will be split as, let us say, a leap year century plus remaining centuries. Leap year centuries plus remaining centuries. So 1900 is equal to leap year century, which is 1600, plus remaining centuries, that is 300 years. Clear? Okay. After this, now, on which date does a year get completed, or which is the last date of a year? Please tell me. Obviously not, Rangaraja. 1600 plus 400 is 2000, not the year more than the number. It has to be previous one only. So again, it is 1900 only that you will consider. previous, lesser. So it was 31st December, obviously. So a year gets completed on 31st December. A year gets completed on 31st December, right? So how many years have been completed till 1947, after 1900? So what you do is, whatever is the current year given to you, 1947. See, 15th August 1947. So we call 1947 47 as the current year. We are in 1947. So this -1, these many years have been completed. These many years have been completed. Okay. So 46 years have been completed. So now you look at the account from the left. Count 1600 plus 300, 1900 plus 46. So we have reached 1946 years. All right. We got an account of 1946 years. So now what are these? These are 46 years. Now, how do you find out the number of odd days in these 46 years? Well, obviously, what do? You divide it by 4. These many leap years you add, all right? Then only you will get the number of odd days. Remember, this is what we discussed. So in 46 years, how many odd days were there? 46 plus 46 by 4. That is the number of odd days. So till 1946, we have reached here. Okay, because 1946 years have been completed. 1947th year is not completed because it will get completed on 31st December. And we are right now currently on this date, 15th August. Okay. So please remember, in short, what do you do is the current year, whatever the last 2 digits are there, -1 you take and write here as the number of years completed. Now let us write down the account of 1947th year. And while writing down the account of 1947th year, where do we start with? From January. So you have Jan, remember, Feb, March, April, May, June, July, August. August, which one? 15th. That is your complete account of the date. Why 1 deducted from 47? I just explained, Bhavna, because 46 years have been completed. But 47th year, we are only in 15th August. It is not completed. When will 1947th year get completed? On which date? 31st December. So the rule is subtract 1, because up to 1946 years have been completed. So we have 1946, 31st December, because a year gets completed on 31st December. But 1947 is the current year. So here I have written the current year's account from January to August. Is this clear? Okay. Now, we already have 1 odd day here in 300 years. So now if you look here, 46 plus 46 by 4. So you have 46 plus, how much is 46 by 4? The quotient only you will take. That is 11 leap years. So what do I get? 57 odd days. All right. Now 57, you know, is a number which is greater than 7. Goes by 56. So 1 odd day you get here. So 1 odd day in 300 years, 1 odd day in these 46 years. Okay. Now write the account of January, February, March, and so on, as we have done previously yesterday. This is what? A non-leap year, right? Non-leap year means February has 28 days. Means 0 odd days. So anyhow, beginning with January, 31 days. So 3 February, March, April, May, June, July. August 15th is the date. The last date we always divide directly by 7. Do you remember? So 1 odd day. And if you remember, what did we do yesterday? We kept on cancelling 7 at a time, wherever you can. All right. So 232 is gone. 313 is gone. So you are still left with 3. Now look at these. 1 plus 1 plus 3, total 5 odd days. Okay. Now kindly consider this. 1, 2, 3, 4, 5, 6, 7, or let us say 0. Why 0? 7 divided by 7, remainder is 0. First day of the week, Monday. Second day of the week, Tuesday. Third is Wednesday. Fourth is Thursday. Fifth is Friday. Sixth is Saturday. And seventh day is Sunday. So basically, this is indicative of the day of the week. Just give me some time. I'm going to make you solve 5-6 questions. All right. So don't worry. Have patience. Have patience. Have patience. First question, you'll understand something. Then second question, you'll understand more. Third question, you will understand more. All right. So have patience. So fifth day of the week. Which is the fifth day of the week? Friday. So your answer here should be Friday. So choice A will be the answer. Okay. All right, sir. So I'm summing it up. To sum up, once again, I'm doing it on a fresh sheet of paper, 15th August 1947. First step, find out the nearest century, obviously lesser. How can you find 2000? So even if you have 1999, take 1900 only. Don't take 2000. All right. In division, what do you take? The number which is greater or the number which is lesser than the dividend? Always the number which is lesser than the dividend. Huh? So first you have 1900. So how are you splitting 1900? 1600 plus 300. Okay. Why 1600 plus 300? Because this is a century, which is leap year. And up to 1600 years, the total number of odd days shall become 0. Why 0? 100, 200, 300, 400. The number of odd days are 5, 3, 1, 0. So 400, 0. So 800, 0 odd days. 1200, 0 odd days. 1600, 0 odd days. 2000, 0 odd days. And in 300 years, well, we have 1 odd day. Clear? All right. And I have clearly stated here also, if you see, here, all these years, see, 1900 is same as 1 in total. So split 1900, the nearest century, as 1600 plus 300. All right. Then whatever are the last 2 digits, the number formed by the last 2 digits, all right. 1947 years have not been completed. After 1900, 47 years are not completed. So how many years are completed? 47 minus 1. Okay, so take 1 year less. That is 46 years. A year gets completed on 31st December. So 1946 years now are completed. Now the question is based on 1947th year, that we will write separately. So whatever is there, that we will write separately. So 46 years have how many odd days? We will find out the leap years. How do you find out the leap years? 46 by 4. Then the 1947th year, I'm writing from Jan to 15th August. So Jan, Feb, March, April, May, June, July, up to August 15th. All right. So how much is this? This is 46 plus 46 divided by 4. How much is the quotient? 11. So we get a 57 odd days, which obviously is greater than 7. And odd days should always be lesser than 7. So you divide this by 7, you get 1 odd day. Correct? Lovely. So 1 here, and this is what? 3032323, and this is 1. Why 1? Because 15 is divided by 17 directly. Last date, you know that. Yesterday I taught you, right? And we keep on removing 7 at a time. Okay. So 1 plus 3 in total, we have 5 odd days, and this is indicative of day of the week. That is 5th day of the week. 5th day of the week is a Friday. Now it is clear. I've told you 2 times. Sam, just hold on here. This is the first question we are doing. Don't immediately shower me with your queries. If it is 31st December, then we will take 31st December only, sir. Okay, because year gets completed only after 31st December is over. That is on 1st January of the next year. All right. What is there to repeat, Santosh? I have already repeated twice. Okay, so it's your problem if you are not understood. Because today I don't intend to waste any time in repeating. So what I'll do for you is this. I will solve another question. All right, guys, tell me what is the date today? Date. Hey, what is the date? Ah, lovely, 4th January, is it? So you have to find out the day of the week on 4th January 2024. You know the answer. You know the answer. It is Thursday. But how can you find out with this method? So the nearest century here is, as it is, we know, it is 2000, and 2000 itself is a leap year. So 0. Then do you have any century from 2000 to 2024? No century, no. So what do? Last 2 digits 24. So make it 23. Why? -1. Because 23 years are completed, obviously. And we are on 4th January. 24th. 2024 is not completed. It is just started 4 days back. Okay. Now the account of 2024th year. All right. But before that, 23 by 4 leap years we will add. Okay. Then January what? 4th of 2024th year. This is the hisab. So how much is this? 23 plus 23 by 4. So 23 years plus 23 by 4. 4 6 are 24. Aha, missed it by 1. No? So 4 5s are 20. Okay. So what do we get here is 28 odd days. 28 is a number which is exactly divisible by 7. All right. So you get a 0. So 0 here, 0 here. So January is what? How many odd days? 4. Oh, 0 plus 0 plus 4, 4. So 4th day of the week, Thursday. Correct, Subhash. Yeah. Don't worry, Megha. I'm going to make you solve 5, 6 questions. Hold on. Don't worry. So in this question, you should have caught more. I think you must have learned more. Huh? You must have learned more. Interesting. No, it will be useful for you throughout your life. You can find out day of the week on any day. You know, that is how it goes. Any date you can find out, actually. Now, let's try and solve this question. We already have a question, right? Which day of the week fell on 26 January 1950? What is the first step? Nearest century. Which is the nearest century? 1900. How will you split it? How will you split 1900? Tell me fast. Fast. Every step now you type fast. So 1600 plus 300. How many odd days in 1600 years? How many odd days in 300 years? Yeah, in both. Yes, Surya, correct. 0 and 1. 0 and 1. What is the next thing you do? 50, last 2 digits. So what do? 50 minus 1. What do we have? 49 plus 49 by 4. 49 plus 49 by 4. And then 1950th year, you have only January here till 26 January. Got this? You understood how I have made this? Yes? So very simple. So 49 plus 49 by 4. What do you get here? Huh? It is 49 plus, well, 12 fours are 48, right? So 12 leap years. So you get a 61 odd days. 61 is a number greater than 7 minus 56. Okay. So you actually get 5 odd days. 1 here, 5 here. And 26th, when divided by 7, again gives you a 5 here. So 1 plus 5 we have 11 odd days. 11 is again greater than 7. Okay, so minus 7, we should get 4 odd days. So fourth day of the week is Thursday. Got this? No, Ganesh, no. Don't do that. What if you get something, in 1359 AD? You can't do all these things. 28, 6, 11, 11 will not be useful. It will take a lot of time when you go back, go back, go back. If you keep on doing that. All right, which day of the week will fall on 7th October 2022? 2022 nearest century, 2000, which is a leap year. Yes, so 0. Any century between 2022 and 2000? No century. So directly now we move on. So 22 is the current year of the question, minus 1. So what do you get? 21 plus 21 by 4. All right. Plus January 7th of 2022. Why did I take January 7th? Why am I not writing from January to October? Why am I not writing from January to October? Why am I only writing January 7th? Why am I not considering from January to October? Yes, Deepika, yes. Correct. Yes, Madhumita, correct. So you know that in a non-leap year, January and October, they have the same calendar. Remember, non-leap year, Jan, October. Leap year, Jan, April, July. Non-leap year, Feb, March, November. Leap year, Feb, August. Then March, November, April, July, May, next Jan, September, December. So rather than calculating from January to October, directly you can write down for January. That way you will save time also. Okay, so this is 0. So let me just use a different color here for representing the odd days. Odd days. So 2000, 0. Here collectively, how many? 21 plus 5 leap years. 4 5s are 20. 4 5s are 20. All right, 21 when divided by 4 gives you 5. So that is 26 odd days. Now 26 is a number which is greater than 7. So goes by 21. We get 5 odd days here. All right. And here we have what? 7. 7 when divided by 7 obviously gives you 0 here, no? So 0 odd days. So only 5 odd days then. 0, 5, 0. You have only 5 odd days. So has to be a Friday. Okay, so none of these is the answer. Wait. We will do CSAT question later. All right, collectively. All right, I want you people to find out 12th September 1981 was which day of the year? 12th September 1981 was which day of the year? Come on, hurry up. Come on, Shabash, you can do it. Come on, Shabash, you can do it. Yes, Akula, perfect. Very good. Perfect, Dikshit. Very good, Ramit. You got it. Yes, Megha, you got this. Yes, Subhash. No, that is all right. 80 plus 80 by 4 only, no? That is 80 plus 20 you will take, no? No, Satakshi. No, Palak. You're committing an error somewhere. And don't worry, this is the first question I'm making you solve with your own hand. All right? If you solve such 10 questions, easily you'll get it. Don't worry. No Shreyank. No Kiruthika. No Arshita. Yes, Anshu. Yes, Sadhana. Yes, Ayush. No Govind. Yes, Devi. No Anjali. No Ritika. No Suchitra. Yes, Dhara. No Vanshika. Yes, Shreyansh. No Madhumita. Yashpal Singh. No. No Jia. Yes, Vechshri. No Sejal. Yes, Sahil. No Yasmin. No Amala. Acha. Now, so many answers coming, so I can't just read it. So, what is it that first thing that I need to do? 1900 is the nearest century. So, split it as 1600 plus 300. Arey, why don't you just memorize? No, 1900 years have one odd day. 1600 plus 300. 1600 has 0, 300 has 1. So, anyhow, now 81. What do you do? 81 minus 1. So, that is 80 plus 80 by 4. 80 plus 80 by 4. Then, from January to September. Okay. So, Jan, Feb, March, April. Now, what is this? This is 1981st year. Jan, Feb, March, April, May, June, July, August, September. Which September? 12 September. Right? So now, sir, this is 0. This is 1. Okay. And how much is this? 80 plus 20. That is 100 odd days. Divided by 7. Goes by 7. 30. 28. So 2 odd days. Jan, Feb, March, April, May, June, July, August. So this is 5. 12 divided by 7. You get 5. Okay. Now keep cutting. Do your cuttings. Cutting part has to be done. Donezo. Alright, sir. So 232 is out. Okay. Alright. 5 and 2 are out. 5 and 2 I have cut here. No issues. 331 I have cut here. Okay. So what remains is 3 plus 3. That is 6. Okay. So 6th day of the week is Saturday. How get 5 separately? Are 12 divided by 7, Ray. 12 September is the date. 12 days in September we have to take. So how many odd days in 12 days? Minus 7. 5 odd days only. Till 1st to 12 September. 1st to 12 September. Only 12 days we are taking. Don't take full September, no. Calculation went wrong. Don't worry. Don't worry. Don't worry. Don't worry. Don't worry. Don't worry. All good. Let me give you another question. Okay. So 11th June 1986. Previous answer. Mohan Raj is Saturday. Yes, Megha, correct. One odd day for 1900. Directly you can take. Yes, correct. Megha, you're going good. 0 plus 2. Subhash, 0 plus 1. 300 years, no? 1 odd days. Correct, Devi. You got it. How to disable? What is disable? Akash, you mean to say divide? No, Bhavan. How to divide? I can't teach you that. Correct, Ayush, Vechri, Mahesha, no Dhara, no Ramya. Yes, Madhumita. Yes, Shubhangi. All right, let me do this for you. So, which is the first century? 1900. So, as it is, you're going to write it as 1600 plus 300. Correct? So, 0 here and 1 here. Odd days. Plus, what do you do? 86 minus 1. How much is it? 85. Plus 85 by 4. All right. Then 1986th year. All right. From January to 11th June. So, Jan, Feb, March, April, May, June. June 11th. Okay. So, let's start playing here. So, how much is 85 plus 85 by 4? 85 plus 4 twos are 8. 4 ones are 4. So, 21 leap years. Okay. So, how much do you get here? 106 odd days. 106 is greater than 7. So, divide by 7. You get a 36. So, 35. So, 1 here. Jan. Now, 86 is anyhow. Please know this. This is non-leap year. No? So, Feb is 0. March, April, May, June 11th. So, 11 days we have to consider in June. Divided by 7. How many odd days? 4 odd days, right? So, 4 here. Cut 3, 4. 1. Huh? Okay. 3, 3, 1. Gone. Remainder 2 and 1. How much? 1 plus 2 is 3. Third day of the week. Wednesday. Third day of the week. Wednesday. Vanshika, देखो कहाँ पर गलती हुई है. See, it is important for you to know where you have committed an error. Ritika, देखो. Just find out, Rachita. Suchitra. Sorry. Lovely. Subhash says, sir, I solved without pen and paper. Lovely. Very good. Sadhana, correct. Perfect, Bekha. Sir, when we add 21 leap years to 85, then we get odd days. Now, because they are greater than 7, so we divide by 7. Absolutely correct. Very good, beta. Shabash, you got it. What a mistake, sir. Sorry. No, sorry. No, punishment for you is solve the next question correctly. Okay. Cancellation, 7 at a time, Kritika. Wherever there is a sum of 7. Wherever there is a sum of 7. See, here. What am I getting? 3 plus 4 is 7. So remove 7. Because you're going to divide it by 7, no. So removing 7 initially itself is division. What is division? Continuous subtraction. Okay. So this C, 3 plus this wala 1, 7. So what remains? 2 and 1. Okay. Is it clear? Ayush also solved it without pen and paper. Very good. You take us in an optimistic way despite we committing mistake. That is my job, actually. Only thing is that I want you to ask more relevant questions and catch it fast. That is what is required. All right. Oh, you saw my TEDx video. Oh, it wasn't good, but then fine. Thank you so much. Karthik, be sorry for yourself because you have missed something great. All right. So you watch the video at least. All right, guys. My next question to you is: find out the day of the week on which you were born. कब पैदा हुए थे? So whichever date on which you were born, find out that date. Which day of the week you were born. So find that out with this. If you know which day of the week you were born, and it matches, and you are able to find that as an answer by using this process, that means you have learned it. And if at all you are not able to, then see where you have committed an error. And if you don't know on which day of the week you were born, so today you will be enlightened with that fact. You can check it on the calendar in your cell phone. Okay. Good morning, Kushi. Very late. 7 o'clock, is it? Megha, sir, give some for homework, then we will check on Google. Homework is check on which date of the week your father was born. Check on which day of the week your mother was born, your brother was born, your sister was born, your dadi, dada were born. Okay, and check it on calendar. Best thing. Okay. How can we calculate for 2002? 2000 plus 1, and then whatever the month is there. For September and October, 2 odd days in month of September, complete month of September, and 3 odd days in the complete month of October. If you're getting your answer as the same, lovely. Yes, Mahesha is getting. She's got it. Okay. So anyone else who got it? Preeti, 2004 is 2000 plus 3. 2004. What will you do? 2000 plus 3. See, 4 is the year, no? So 4 minus 1. So 3 plus 3 by 4. 3 by 4 is what? 0 only, no? How will you divide 3 by 4? Can you divide 3 by 4? No, the number should be greater than 4. Okay, then whatever the months are there, whatever the months are there. You got it. All right, Ritika got it. Janvi got it. Roshan. Roshan has asked a wonderful doubt. Sir, will there be a question on Hindi calendar? Oh, I'd nice joke. No. 2001 is 2000. And directly you write the month then of 2001. Pradhyun. Sorry, Pradhyus. Pradhyus, give me the date. No. 1 comes means Monday. Sunday is 7. 7th day of the week. Kritika. No, I'm not asking you dates. I want only Pradhyus dates. I will become a human calendar soon. Tell me your date, Jia. Then if you were born in 2000, then tell me your date. Vanshika, 10th August 2004 is what? 2000 plus 3 by 4 plus January to August. All right. And when you're taking January to August, because 2004 is a leap year, don't forget that February will have 1 odd day. Tell me, Vechri, what is your date? All right. Let us find out on which day of the week Vechri was born. Okay. Now everyone will not tell me, sir, my date. Pratyush, I asked you your date there. I'm not able to. 7th October. Aha. Before we do that, Pratyush's date is 7th October 2001. 7th October 2001. So, guys, what do you do? 2000. Any century between? No. How many years? 1 minus 1, 0. So, 0. How many leap years? 0. Next year only you're asking, no? So, 2000 plus easiest of all, Jan 7th of 2001. So, this is 0. This is 0. Sir, you were born on a Sunday. Okay. So, Vechri has got 16th September 2002. Correct? Let's find it, guys. Okay, so 2002 means 2000 plus 2 minus 1, so 1 plus 1 by 4. 0 only, no? 1 you won't divide by 4, no? 1 cannot be divided by 4, no? All right, so plus up to 16 September. So Jan, Feb, March, April, May, June, July, August, September, 16. So this is 0, this is 1. Okay. This is anyhow a non-leap year, so February is 0. So this is 3, 3, 2, 3, 2, 3, 3. So 16 divided by 7. You get 2. All right, so keep on removing 7 at a time. Remove 7, 3, 3, 1, gone. 2, 3, 2, gone. All right. So this is what is left. 3 plus 3 plus 2. Okay, you get 8. 8 minus 7 is 1. So born on Monday only. Huh? Your mother is right. Why are you getting as Tuesday? अच्छा अभी बैठ के मैं मतलब till 9:30 I should find out the day of the week on which everyone was born. Is it enough? Now practice. Now practice. I think we have solved enough number of questions. Now we are going to solve some more questions also. Okay. So look at this question. One day before. Where is that? Yes. Find out for this. This is CSAT 2021 question. Come on, guys. You can solve this. You can do this. Come on. Come on. Hurry up. Hurry up. Come on. Come on. Come on. देन ये क्लास शुरू होते होते ही खत्म हो जाएगी करेक्ट यस यू गॉट इट शाबाश उसना मेघना आयुष श्रेयश सुमित कृतिका ऑल करेक्ट नो सतीश यस देवी यस सोनम यस धारा यस ऋतिका नो ऋतिका थोड़ा कैलकुलेशन मिस्टेक कर भाई यस प्रियंका नो श्याम यस जानवी सरिता रेशमा नो जानवी सरिता यस रेशमा नो यस अक्षित सुभाष गिव मी योर आंसर डियर Preeti, yes. Muhammad, yes. Manmohan, yes. Amala, yes. Mahesha, yes. Darla, yes. Vanchika, yes. All right. No, Swati, no. Swati, no. Swati, no. Swati, no. Swati, no. No, Ritika, no, Ritika. No, Tazin. No, Roshan, no. No, Mohan. All right, sir. Let's start. So, what is the first thing that I should do? You tell me. You tell me. What should I write? 2000 plus any century in between? No. So, it should be 27 minus 1. Remember? Now, see where you committed an error. So 26 plus 26 by 4. All right. And this happens to be what? Non-leap year. In a non-leap year, Jan, October. So directly you write January 10th of 2027 over. Okay. So 2000, 0. And how much is this? 26 plus 26 by 4. Huh? 4 6 24. So you have 6 leap years. So that is 32 odd days. 32 divided by 7 goes by 28. So 4 here. January 10th, so 10 divided by 7, remainder is 3. अरे यार इसको सर्कल करूंगा तो लफड़ा होगा 4 plus 3 is 7. 7th day of the week is Sunday. So see where you committed an error. Now I have another question for you. Look at this. Which date of June 2099 among the following is a Sunday? See, till now what we were doing, we were finding out the day of the week for a date. Now, day of the week is already given to you, and you have to find out the date. So don't worry. What is given? June 2099. Find out for 4th, because this is the least of the choices. 4, 5, 6, 7. So according to 4, we will find out. If 4 is Friday, then 5th is Saturday, and 6th is your answer Sunday. If 4th is Saturday, then 5th is Sunday. Maybe 4th is Sunday. Likewise. So my point is, find out for 4th June 2099, and accordingly you can find your answer. So let me do it for you now. You people have become experts, right? So 2000 plus 99 minus 1, correct? That is 98 plus 98 by 4 plus 2099th year. We have to go from January to 4th June. So Jan, Feb, March, April, May, June. June 4th. Okay. Now let's start. This anyhow is 0. How much will this be? 98. Okay. Plus 24. 4 twos are 8. 18 remains. 4 fours are 16. These many leap years. So this is what? 122 odd days. 122 divided by 7. Okay. So you get a 52 here. Goes by 49. So 3 remainder. Now this anyhow is a non-leap year, right? So 0 here. So 3 here. So 3, 2, 3. And June 4th is 4 only, right? Do your cuttings properly. 4 and 3 gone. Okay. Now here you have 3 plus 3 plus 2. 3 plus 3 plus 3. Sorry, 3 plus 3 plus 2 is 8. Again, minus 7 should give you 1. So now these two, 3 plus 1 is 4. So it is a Thursday. Correct, correct. Yes, yes, you got it. So if this is Thursday, this is going to be Friday, this is going to be Saturday, and this is going to be Sunday. So D is the answer. Cool, easy. How do you find it? A का मतलब yes, B का मतलब no. Tell me, how do you find it? Good? You find it good enough? Useful? You can find out the weekday for any date now. This year, when is your birthday? Find out on which day of the week it falls. Okay? 97%, lovely. 2000 is 0, no? Megha. Year 400, 800, 1200, 1600, 2000. Each of these is divisible by 400. That is why these are leap year century years. These are leap century years. All right. So 2000 is 0. That's it. Got it? Okay, Megha. All right, sir. So that is it. We move on to now my favorite topic also, and that is syllogism. Meghna, 20th Feb 2000, you will have to take it as 1999. All right, this one I want to solve. This one I want to solve. This one I want to solve. 20th Feb year 2000. Let's do it. Last question. So you always know that current year we will never take. Okay. So that means we will have to take till 1999. Current year we don't take, no. -1 we will take, no, only. So century here is 1900, gets split like 1600 plus 300. 1900 years, right? So as it is 2000 -1. Okay. So you will have 99 years plus 99 by 4. And then January, February 20th, this is year 2000. Get it? So what is the issue? 0 here. This is 1. All right. So 99 plus 99 by 4 is what? Again 24. So 99 plus 24. So you get 123 odd days divided by 7. 53 goes by 49. So hence you get a 4 here. January is 3. February 20th is 6. So you get a 6 here. Now see, 1 plus 4 plus 6 is 11. So goes by 7. 4th day of the week, you were born on a Thursday. Check it on the calendar also. All right, sir. So I'm going to begin with syllogism now. Not confident in syllogism, right? Don't worry, it will come to you. Which three left? Arey, my fault. Thank you, thank you, thank you. Thank you, thank you, thank you. Thank you, thank you, thank you, thank you. In fact, what we are supposed to do is this. My fault, no? 4 and 3 we will cancel, no? So now we are left with only 6 and 1. 3 I didn't see, sorry. So if such mistakes are happening, no problem. Human error, that can be caught. Okay. So now what do I have? I have this 1. This 4 I'm cancelling with 3 and I'm left with 6. So 1 plus 6 is 7. Actually, it should be a Sunday. Just check, no? On the calendar. Were you born on a Sunday? Correct. All right. Okay, sir. So that is calendars for you. So just go ahead and practice. Okay. Now when I talk about syllogisms, see, there are questions which are based on 1 statement, 2 statement, 3 statement, 4 statements. All right, and there are 2 methods of solving the questions: Venn diagrams or tick cross method. This is how a statement looks like. All A or B. This all is called a quantifier. A is called the first term. You can call it the first term. All right. It is also known as subject term. But if you are not comfortable with the words like subject term, then skip it. Call it first term. And B here is the predicate term. Okay, forget it. Forget it. Forget it. Don't worry. So this is second term. So any statement in syllogism will look like quantifier, subject term, predicate term. Quantifier, first term, and second term. That's what it will. Now, what is the meaning of the term quantifier? Quantity. So any term which specifies, or any word which specifies a quantity, is called a quantifier. How many A are B? All A are B. How many A are B? No A is B. How many A are B? Some A are B. How many A are B? Some A are not B. So majorly we are talking about 4 quantifiers: all, no, some, and some not. See, I heard you. Some of you said all, some. No, no. You have to memorize it in this order. Please do so. So speak with me, along with me, for 3 times. All, no, some not. All, no, some not. All, no, some not. All, no, some not. Clear? Got it? No, no, Shreyank. Should we use what rules of inference of discrete mathematics not required? Right? Just use whatever I am teaching you. Over. Okay. Now let's move ahead. Now see, there are 2 methods with which these can be solved: Venn diagrams and tick cross method, and I'm going to teach you both. I will teach you both. Okay. So what are Venn diagrams? You already know. They are diagrammatic, pictorial, graphical representation of sets. All right, making use of geometrical figures. And most of the time, the geometrical figure that is used here is a circle. So all questions in syllogism can be solved with the help of Venn diagrams, but Venn diagrams at times are tedious. You tend to forget a diagram. Okay, that is why you jump onto incorrect answers. Although I'll tell you a process for that as well. So after knowing, or after going through the Venn diagrams process and learning that, then we will shift to another method called tick cross method. Actually, it is also called distribution method. It is actual syllogism. with the help of which you should be able to solve the questions within 15-20 seconds. But there are many questions which cannot be solved with tick cross method, and that is why you need to know Venn diagrams. Venn diagrams form the very basics and the basis of logic. So, chalo, first learn Venn diagrams for each of these quantifiers. So let us draw Venn diagrams here. Okay. So all ARB, this is the first one that I'm picking up here. What is the meaning of the statement? Listen to me carefully. Now you have to listen very carefully and you have to repeat whatever I ask you to repeat. Okay. Now stay put. No interfering thoughts. All right. And don't ask me a question. Don't spoil my flow unless I have completed a portion. Okay. Because I'm not going to look at the chat now. All ARB. Now what does it mean? It means that each and every element of set A is in set B. If I talk in terms of sets, all ARB means A is a subset of B. If I draw and represent sets A and B through circles, then set A circle should be inside set B circle. It cannot be, no portion of set A circle can be outside circle B. All right, no portion of circle A should be outside circle B. Correct or not? Now you tell me. You agree? All ARB, every element of set A is inside set B. Correct? Agree? Lovely. So let us draw those diagrams in which set A circle is not outside set B circle. Can I draw like this? Do you agree? I'm giving you a poll. I'm giving you a poll. All right, so just mark your poll here. Very fast, very fast. Can I draw like this? All ARB. Very fast, put in the poll. Now there is no time for you to, commit any mistake. 93%. All right. Now, can I represent it like this? Tell me. Tell me through your poll. All ARB. Fast, fast, fast. %71%. See, because people think that, no, sir, this is all BRA also. Forget that. No, all ARB, yes or no? What is the meaning of all ARB? That no part of circle A is outside circle B. It should be within circle B. So they can superimpose also, no? Okay, so this is correct diagram. Now, please remember, whenever you draw Venn diagrams, you have to draw two Venn diagrams, at least two Venn diagrams. Okay, so draw at least two Venn diagrams. Okay, one you have to draw for least intersection. All right, and the second one, maximum intersection. So least intersection, maximum intersection, least intersection, maximum intersection, least intersection, maximum intersection. That will cover the two extremes. So these are the two diagrams for all. Please know this. So you pick up any member of A. It is inside B. Pick up any member of set A. It is inside B. So here it's a different story that set B is also a subset and a superset of set A. So be it. Doesn't matter. But no part of A is outside B. This is a maximum intersection between A and B. So whenever you draw a diagram for all ARB, you draw these two diagrams. Please know this. Now let's have a look at the second one. That is no A is B. What does it mean? Not even a single element of set A is inside or is having an intersection with set B. So set A and set B should be two disjoint sets. So do you agree? Do you agree? Please tell me. This is a diagram that will represent, this is the only diagram which will represent no A is B. Do you agree? %95. All B is not A. So I'm not talking about B, Ritika. I'm not talking about B. How many B are A? I'm not bothered. But all A are B, yes or no? Absolutely yes. All right. Here also all B are not A, no. They're outside A. Okay. So anyhow, coming back to this, let's have a look at something which is more specific. Now, before I do that, see all and no, if you pick up any element of set A, when I have no A is B, that means any element that you pick up from set A, it is not in B. Any element. So it is applicable to each and every element of set A. Pick any element of set A. What is its characteristic? It is not in B. When you say no A is B. Okay. And when you are saying all A are B, you pick up any element from set A, it is going to be in B. All right. So these are applicable to each and every single element. So hence, all and no are called. अरे यार क्यों हो रहा है ऐसा यहाँ पे? Universal quantifiers. All right. All and no are universal quantifiers because these statements are universally applicable to each and every single element. Universal truth is what? Which is true for everyone. Okay. So when we have all and no, they talk about each and every element. Okay. Please know this. Now we have sum. Now tell me what is the meaning of sum? What is the meaning of sum? Please tell me. What is the meaning of sum? Absolutely. Anjali, where did you read it? Deepika, where did you get it? Rajneesh, where did you get it? Shreyash. At times I'm not pronouncing your names properly, I think. No, where did you get it, Sejal? Jia, where did you get it? Astha. Hey, you people are assuming actually here that some means not all. Where did you read it? Nowhere. You haven't read it anywhere. And it is not written anywhere. If any book says, if there is any book which says some means not all, just tear it off. All right? Some means few. Correct. But when I talk about, syllogism, please know we are talking about sets. In case of no, when we have a statement no A is B, in case of no, now listen to me. In case of no, when we have a statement no A is B, all right, it means that there is no intersection between A and B. No A is B means no intersection between A and B. Correct? Some A are B, some means intersection is there. Intersection is there, intersection exists. All right. Now, for that intersection to exist, answer me. I'm asking you a question. For that intersection to exist, how many elements should be there in that intersection? It cannot be empty, no. So, how many elements should be there for that intersection to exist? Absolutely correct, Shri Hari, Vechri, you got it. So, please know this. Yes. You got this. Lovely. Not 50-50. Why 50-50? Huh? Just like that, is it? JLT. So please know you have learned something here, and that is now onwards, sum means at least one. So when you say sum A or B, it means at least one A is there, which is B. What about the remaining A's? I have no information. I have short, definite information about one A, which is B. When I say sum A or B, it means I have information about at least one A. Others I don't know. Other A's may or may not be B. I don't know. Okay. So as to say, what is the range for at least one? It means from 1 to all. That is 1% to 100%. I write an examination. I write an examination which has got 100 marks. All right. I write the examination. I come out of the examination hall and you are standing there to greet me. Sir, how was your paper? How many marks will you score, sir? And I look at the paper, I calculate this question, and I say, out of 100, at least 1 mark. Means what could be my score? My score could be anything from 1 to 100. Get it? It could be anything from 1 to 100. All right. So that is what it means. So that means we will draw each and every diagram wherein there is an intersection between A and B, where there is an intersection between A and B for sum. Okay. Tell me. Can I represent it with this diagram? Sum A or B? Yes or no? Tell me. Mark in the poll. Mark in the poll very fast. Very fast. Sum A or B can I represent it with this diagram? Come on, mark it in the poll. Very fast. 98%. Lovely. Then can I draw this diagram? Let us say sum A or B. Very fast, very fast, very fast, very fast. Ji. Hurry up, ji. Sum A or B. Can I say sum A or B in this diagram? Yes, Jagan. Focus on the subject right now. 84%. Why? Are, what is the confusion? Let us say A is India and B is UP. Some part of India is in UP. The other part of India is in Maharashtra, Tamil Nadu, Karnataka, Andhra Pradesh, Kerala, Assam, Manipur, Punjab, Madhya Pradesh, Rajasthan, Chhattisgarh, and so on, Bihar, West Bengal. So, some part of India is in UP. Is correct. Although complete UP is inside India, but some part of India is in UP. Absolutely. So these are there. So there is no discussion on this. I think we should have a discussion on this. Look at this diagram. Can I use this diagram? Can this be one of the cases? See, whenever you draw a Venn diagram, you draw a Venn diagram for each and every single possibility. And when we are drawing two Venn diagrams, one is with least intersection and maximum intersection, we are covering every possibility. Okay. So just tell me, can I represent it with this diagram? Just tell me, please. Sum A or B, can I represent with this diagram? Can this be one of the cases? Can this be one of the cases? One of the possibilities? One of the situations for sum A or B? 70% say yes. Hare Baba, why not? What is sum? At least one. What is at least one? One to all. 1% to 100% intersection. Huh? So even this can be, and even this can be used or can be one of the cases for sum A or B. All right. So I think we have seen these diagrams somewhere, no? Haven't we? Here. So these are diagrams for all. These are diagrams for all. Same diagrams are used for all. Okay. So from this we learn. From this we learn. From all we get some. 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 All right. So whenever you have a statement in terms of quantifier all, let us say all A R B, we can get a conclusion in terms of sum, that is sum A R B. See, if all the students in my class are intelligent, I'm giving you an example, huh? Don't take it to your heart. So all the students of my class are intelligent. That means I pick up any one student. He's going to be intelligent. True or not? At least one is going to be intelligent, for sure. But when I say some of the students of my class, some students in my class are naughty. It means what? At least one student is there. I'm confirmed about one student who is naughty. Others, I don't know. They may or may not be naughty. All right. So how many are naughty? Maybe 1%, maybe 100%, maybe 50%. I don't know. 1% I'm sure of. At least one I'm sure of. All right. So from all we can get some, but not the other way around. From some we can't get all. From all we can get some, but from some we can't get all. Right? Now is this clear? Diplomatic answer. Okay. So please know this. Now let's have a look at sum A or not B. That is the fourth and the last quantifier here. Sum A or not B. What is the meaning of that? Sum. We have sum here, no? What is the meaning of sum? At least one. So there is at least one A which is not B. That means at least one portion or part of circle A will be outside circle B. At least one means at least one part of circle A is going to be outside circle B. 100% भी हो सकता है. It can be 100% also. Why? Because sum means 1% to 100%. Remember? 1% to 100%. Okay, that is from 1 to all. So let me draw all those diagrams in which I can show it. Okay, let us say this is A and this is B. Some part of A is not in B. Can I represent it with this diagram? Please tell me. In this diagram, using this diagram, this can be one of the cases for some A or not B, yes or no. These are those A's which are not B. They are not in B. Hurry up, mark it in the poll. Become a Marco Polo. 98%. Lovely. Agreed then. Okay, sir. Then can I have it like this? Some A are not B. Again, this is India, this is UP. See the same diagram. So this is India, this is UP. So some part of India is not in UP. It is in other states. So can I draw this diagram? Yes or no? Tell me. Can we have this diagram? Yes or no? As one of the cases. Hurry up. Some part of India is not in UP. Lovely, 95%. Okay. Then can I have this diagram? Some A are not B. Huh? Can I have this diagram? All right. I'm not asking you this time. See, whole point is, can you look at this? Draw at least two Venn diagrams. Least intersection and maximum intersection. You have to draw two diagrams. So here there is least intersection between A and B. Let us say 1% of A is outside B, and here 100% of A is outside B. Because sum means at least 1% to 100%. Please remember. Here 1% of A is in B. Here 100% of A is in B. Okay. So as far as Venn diagrams is concerned, for sum, you draw only two Venn diagrams, this and this. That's it. for 1% and for 100%. Least intersection, maximum intersection. And when you are solving a question through Venn diagrams and you want to draw Venn diagrams, then for some knot you draw these two diagrams: 1%, 100%. Some A are not B. 1% A is not B, 100% A is not B. And as it is, you see, what is this? This is the diagram which is used for no also. Okay, this is a diagram which is used for no also. So whenever we say no, we can say some knot. From no, we get 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 some knot. From all, we get some. From no, we get some knot. From all, we get some. From no, we get some knot. From all, we get some. From no, we get some knot. From all, we get some. From no, we get some knot. All right. That is, if you have a statement, let us say, no A is B. All right. From this, you can derive a conclusion, that is, some A are not B. No cat is dog. That means there is at least one cat which is not dog. So I can also say some cats are not dogs. All right. But as some and some not have the word some, they talk about a particular portion also. Only a particular portion. Why? Because when I say some students are naughty, it means there is one student I'm sure of, he's naughty. Other students, I have no information. So other students apart from this one, if there are 100 students in my class, one student I'm sure of, he's naughty. Other 99, I don't know. They may or may not be naughty. Maybe half of them are naughty, maybe full of them are naughty, maybe no one is naughty. No information. So some gives me information only about a particular section or a particular part. Right? So please know, some and some not, they belong to the category particular, and they are called particular quantifiers because they only talk about give us information about a part. They do not give us information about the complete set, as is the case in all and no. All and no, they give you information about each and every element, sir, complete part. So that is why they are universals. But some and some not, they give you information only about a part. Okay, that is why they are particulars. Okay. So we are done with our Venn diagrams. Okay. So let me just ask you, what are the three things which are there in the structure of a statement? The three things which are there in the structure of a statement in syllogism are quantifier, first term, second term. 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 All right. How many quantifiers are we talking about? Well, now you can type if at all you want. All right. But answer my questions very fast. Repeat. Speak also. So how many quantifiers are we talking about? Tell me. Four. Four quantifiers. Which are those? Which are those? Very fast. All, no, some not. All, no, some not. All, no, some not. All right. Now, what is the meaning of some? All right, before that, which are the universal quantifiers? Which are the universal quantifiers? All and no. Which are the particular quantifiers? Which are the particular quantifiers? Some and some not. All right, now what is the meaning of some? At least one. What is the range for at least one? 1% to 100%. 1% to 100%. Correct? All right. From all, we get some. From no, we get some not. From all, we get some. From no, we get some not. All right. So I hope this is quite clear to you. Okay. So let me just take a poll from you. A ka matlab yes, B ka matlab no. Is this understood? So whatever that I have taught you till now, do you remember? Do you understand? At least remember whatever I have taught. Hurry up. Marco Polo, Marco Polo, Marco Polo. 97%. Good enough. Good enough. Now see, I have a statement some A or B. Then I interchange these two terms and rewrite this as some B or A. Do both the statements mean the same? Will the Venn diagram be the same? Yes. See, some A or B means some B or A. Alright, some part of Russia is in Asia. So some part of Asia is in Russia. When we are talking about some, we are talking about the intersection. See, this intersection we are talking about. An intersection belongs to both the sets. Intersection is a part of set A as well as of set B. All right. So if some part of A is in B, it means some part of B is in A. So that means in case of sum, the two terms can be interchanged. In case of sum, the two terms can be interchanged. So sum A or B can be rewritten as sum B or A. All right. Now similarly, no A is B. All right. It can be written as no B is A. You can interchange the two terms in case of no. In case of no, the two terms can be interchanged. In case of no, the two terms can be interchanged. In case of no, the two terms can be interchanged. Yes? Obviously, no cat is dog. No cat is dog means no dog is cat. It means that. Alright? Apart from that, we know all से मिलेगा some, no से मिलेगा some not. From all we get some, from no we get some not. So no A is B, we get some A or not B. From no B is A, we get some B or not A. There are only two quantifiers, some and no, who are also opposites, by the way. Because no says no intersection. Some says intersection is there. All right, those they are opposites. So in these two, some and no, actually, some and no, the two terms can be interchanged. In case of some, the two terms can be interchanged. Some A or B can be rewritten as some B or A. In case of no, the two terms can be interchanged. No A is B can be rewritten as no B is A. All right, cool. And this sum not that you are deriving from no, here also, can't you see this? That both the terms are being interchanged. But this is a special case. Because in general, in sum not, you cannot interchange the two terms. When can you interchange the two terms in sum not? Only when sum not is derived from no, as is the case here. See, here sum not is being derived from no. Here you have a no statement. From no statement, you get sum not statement. Then in that sum not statement, you can interchange the two terms. Because in no statement, you can interchange the two terms. So from no, whatever sum not statement you obtain, in that also you can interchange the two statements. In no, you can interchange the two statements. So from no, the sum not statement obtained, you can interchange the two statements. In no, no A is B, you can interchange the two terms. You can interchange the two terms. No A is B is written as no B is A. So similarly, from no, we obtain sum not, some A or not B. Here, when sum not is obtained from no, you can interchange the two terms and you can rewrite some A or not B as some B or not A. All right, got it. Okay. Yeah, good morning, Sahil. That's quite early, is it? Okay. Sir, your lecture like magic. Time goes so fast. Are good? No, it is because you people are involved. Okay. Uh, Venn diagram for sum not. Yasmin, Venn diagram for sum not are there in front of you. There are three diagrams. What? Again, you want me to draw these diagrams? Huh? I think if you watch recordings, in fact, you would be able to resolve your doubts. All your doubts will be resolved because I try to be as detailed as possible so that if at all you have a doubt and you watch the video, then all the aspects would be covered. Okay. Now, a quick recap, a quick recap, a quick recap. What are the things that you must keep in your mind when you're coming out with a conclusion? All right. Now, first things we know which are the four quantifiers that we talk about. Which are the four quantifiers that we talk about? All, no, some not. All, no, some not. All right. So, which are the universal quantifiers? All and no. Which are the particular quantifiers? Some and some not. Okay. What is the meaning of some? At least one. What is the range for at least one? Everything is written. At least one is what? 1% to 100%. From all we get some. From no we get some not. From all we get some. From no we get some not. All right. Now, in case of some, the two terms can be interchanged. In case of no, the two terms can be interchanged. In case of some not, the two terms can be interchanged only when some not is derived from no, or it is, an extension of no. Otherwise, if some not statement is seen anywhere, you cannot interchange the two terms. So only those some not statements you can interchange the two terms which are being obtained or derived from no, which are bacha, kid of no. Okay, so they will follow the parampara of no. No interchange, so some not also interchange, the bacha coming out of it. Okay. In all ARB, it is only this that A is less than or equal to B. Yes, correct. Interpretation, Surya. Correct, very good. Anjali has actually, done a better job. She has, sentenced it, or let us say she has structured it in a better way than I have. She says, sir, can I say directly, we can't say some A are not B equal to some B are not A, but from no sentence, we get some not sentence, then in that some not sentence, we can say some A are not B is same as some B are not A. Both are equal. Very well. Okay. All right. All right. Sir, what your Taki Kalam? Acha, Takiya Kalam. Okay. I love that, sir. And Twinkle Twinkle Little Star. Okay. Uh-huh. दिमाग की बत्ती जली और मैं फिर आ रहे वाले thank you. Okay. So everything that I have written, it is here. Let's read it very fast. Read it very fast. Some means at least one. At least one is 1% to 100%. From all, we get some. From no, we get some not. In some, terms can be interchanged. In no, terms can be interchanged. In some not, if some not is obtained from no, only then the two terms can be interchanged in some not. Otherwise, if some not is not obtained from no, we cannot interchange the two terms. Are you becoming the getter of this? Okay, lovely. Okay, sir. So I am going to move forward. So let's take a break so that because after that I won't stop. Okay, and you also won't feel like stopping actually. So let's catch up at 8:10. All right, it is 7:55 by my watch. So let's catch up at 8:10. All right, and please make sure that before you actually sit down, you come at least 2 minutes before at 8:08. Okay, and revise this, whatever is written here. Okay, complete Venn diagrams, complete syllogism is going to be based on these theories and some more, which I will be giving you now. All right, so let's catch up at 8:10. You please come at 8:08 and revise. Wash your face, not with cold water, better with cold water. Okay, but don't put cold water on your head. Okay, but keep on, putting some water in your eyes. Not ice, but eyes. Okay? Stay awake. Let's catch. मिलते हैं ब्रेक के बाद. Anjali has a point here. When I say this sentence, say to my father that at least 1 mark Papa in UPSC prelims, he will give me so-called chata with surprising attack by my mother also. And that is universal. Okay, so it will happen to everyone. So I hope that you have revised this. Betri, Abhishek, others, you can post your doubts at Bajus IS Live, islive at bajus.com. Okay. Anyhow, let's move forward. If two statements are positive, positive means what? We have four quantifiers. Let us say we have all, no, some, and some not. So a positive statement or an affirmative statement is the one which is says yes, yes, all A or B, yes. And a negative statement says no, it's a disagreement. All right. So all A or B, yes, it is positive. No A is B, no, neither nor, never, not is negative. So no is a negative quantifier. Some A or B, yes, it is positive. Some A or not B is negative. Correct. So from positive, all you are getting some, all se milega some. From all we will get some. From no, we get some not. So from negative, negative only. Anyhow, if there are two statements which are positive, the conclusion cannot be negative. It has to be positive. The conclusion cannot be negative. It has to be positive. All right. So if there is one statement which is positive and one statement which is negative, two statements given to you, then in that case, the conclusion obtained will be negative only. You can't have a positive conclusion. Okay. See, simple as that. I'll give you an example. Let us say that you're riding a bike, whichever way you want to form it. All right. Such a bad bike this is. Okay. So let us say that you go to a showroom, you want to purchase a bike, and the showroom guy, he gives you a trial run. So he gives you a bike, gives you the keys, and he goes back into the office, and now you're going to take a trial. Now, if the tires, there are two tires in the bike, if the tires are inflated, both the tires have air. So how will be your experience of driving the uh, the bike? Obviously, it will be good. So if both tires are filled with air completely or they are inflated properly, that means both are in positive condition. So your experience of driving will also be positive. In second case, let us say that you go to a showroom and you take a bike, you get the keys, you start, and the guy has gone into the showroom. okay, inside the showroom, and suddenly you find that one of the tires is punctured. One tire is inflated, proper air, so in positive condition, but the other tire is punctured, so in negative condition. So how will be your experience of driving? It will be negative only. You won't be able to drive it properly. Okay. So if one statement positive, the other statement negative, conclusion, if at all it exists, if at all conclusion can be obtained, it has to be negative. Third case, all right, if let us say the showroom guy, he hands over the key and he goes inside immediately. And suddenly you find that there is very less air in the tires, or both the tires are punctured. That means the condition of both the tires is negative. Then will you be able to drive the vehicle? Obviously not. All right. So simple as that. If both the statements are negative, no conclusion. Now this guy comes and he asks you, sir, how was your experience of driving this motorbike? You will say, what driving? It did not move. Both the tires are punctured. What are you talking? Fill it with air first. Then only I will be able to drive. No. So you can't tell him, how was your experience of driving, because you could not drive it. So three things. If there are two statements and they are positive, the conclusion has to be positive. It cannot be negative. If there are two statements, one is negative and one is negative, conclusion has to be negative. If at all the conclusion exists, maybe there is no conclusion. But if the conclusion is coming, maybe you choose not to drive the bike. Okay. But if you're driving the bike, then your experience is going to be negative because one of the tires is punctured. And if both the tires are punctured, sir, then obviously no conclusion. You can't tell the salesman how was your experience of driving the motorbike, because the motorbike is not going to move. Both the tires should be inflated. At least one is to be inflated, then only it will move. No. Okay. So remember this. Middle term. What is a middle term? It is a common term which is present in both the statements or premises. Premises are nothing but these are statements of information based on which conclusions are drawn. So here we have two statements. All A are B, all B are C. And we have to draw conclusions. Now, before we draw conclusions, let us notice that there are three terms, A, B, and C. And B here is common to both. It is there along with A, along with C. Okay. So B here is called the common term or the middle term. Now, what is the job of a middle term? In short, it is empty. It helps in forming a connection between the other two terms. All right. So as to say, B is nothing but it is a middleman in a transaction. Like between manufacturer and consumer, the middleman is the retailer, isn't it so? So retailer is the middleman acting between manufacturer and the consumer. So B here is the middle term which helps in forming a relation between A and C. Common term which is present in both the premises. Now there are two types of conclusions that we will have to draw, and both are conclusions. So don't ask me, sir, is this a conclusion? First is immediate conclusion, in short, IC. Second is main conclusion, in short, MC. Immediate conclusion can be obtained from only one statement, and main conclusion is to be obtained from both the statements. So I give you the statements, all A are B, all B are C. Now you will get clarity. IC, immediate conclusion. From the first statement, you know that the quantifier here is all. All right. From all, we get sum. From all, we get sum. So conclusion is going to be sum A are B, and in sum, the two terms can be interchanged. So hence, sum B are A. All right. To come out with this conclusion, you do not require the second statement. Now the second statement here is all B are C. From all, we get sum. So all B are C means sum B are C. and in and in some, the two terms can be interchanged also. So some CRB, some BRC, some CRB. These are the ICs, 4 ICs, that is immediate conclusions. Main conclusion now has to be between A and C. Middle term B will cancel. Obviously, the final relation is going to be between A and C. Okay, so in main conclusion, middle term is not there. Usually, that is what we have. Okay. Now let us draw main conclusion. So let me tell you that all these things, Venn diagrams and syllogism process, tick cross method, are made to draw main conclusion only. Okay. For immediate conclusion, there is not a problem. No. For immediate conclusion, you can draw from one statement only. So how do you draw main conclusion? Well, we have learned only one method of drawing main conclusion, and that is through Venn diagrams. So let us draw Venn diagrams for these two statements. Okay. All ARB, two Venn diagrams, least intersection, maximum intersection. All A R B, all A R B. Second statement, all B R C. Merge with this, all B R C. Circle B should be inside circle C. All B R C. B is equal to C. Remember? Okay. Now we have 4 quantifiers. Which are those? Well, they are all, no, some, and some not. Now you also know that this statement is positive, all A R B. This is also positive, all B R C. Okay. And you remember the rule? That is positive and positive. Your conclusion has to be positive. It cannot be negative. This is positive, this is negative, this is positive, this is negative. Our answer cannot be in terms of no and some not, period. So your main conclusion has to be in terms of all, from which we will get some, or it will be in terms of only some. All will not be there. Okay, so let's find out. All A R B. Now, what is the conclusion? Conclusion must be true in all the diagrams, in all the situations, in all the possibilities, in all the situations, right? So, is the circle of A inside the circle of C? All A are C. Is it inside circle A? Is it inside circle C? Yes. Circle A. Is it inside circle C? Yes. Inside means what? Superimpose. Is there any part of A which is outside C in this? Is there any part of circle A which is outside C? No. So from these two diagrams, you can say that all A are C would be your correct conclusion. From all, we get sum. So you get sum A R C. In case of sum, the two terms can be interchanged. So sum C R A, you get 3 main conclusions. Well, can you get all CRA as a conclusion? Obviously not. In this diagram, C is greater than A. Can you say all CRA? Circle C is inside circle A? No. If it is wrong in one and it is correct in the other, that is a possibility, may or may not be situation. Here, all CRA, yes, we can say that because the two circles superimpose. Okay. So if a statement is true in one diagram and false in another diagram, then that statement is a possibility, right? Not a conclusion. Please know that. All right. And a conclusion sorry. must be true in all the diagrams. A conclusion must be true in all the diagrams. So as this is false here, but true here, so this is a possibility, but not a conclusion. Clear? Is it clear? Is it clear, Ray? Give me a thumbs up, Ray. Got it? Lovely. Lovely. Okay, sir. So that is Venn diagrams for you. Now we will observe 7 rules of syllogism. And in those 7 rules of syllogism, I will keep on giving you examples. Now we will verify each of the example through Venn diagrams because that is the only process, only method that we have learned till now to solve questions. Okay. Till we learn the 7th rule. After the 7th rule of syllogism or 7th rule of tick cross method, then we will apply only those 7 rules. Then we will leave Venn diagrams. Okay. All right, sir. 7 rules of syllogism. We talk about the first. All right. So wherever possible, just try to come out with the ICs. Tell me, what is the IC that you obtain from the first statement? Very fast. Very fast. What is the conclusion for all ARC? Conclusion is all ARC, Megha. Tell me, what are the ICs, immediate conclusion that you can draw from all ARB? No, Aarti, all BRA is incorrect. In case of all, you can't interchange. The interchange can happen only in case of some, in case of no, and in case of some not if some not is obtained from no. In case of all and in case of some not in general, no interchange will take place. Yes, sir, you got it. So it is going to be from all we get some. From all we get some. So some A R B, interchange allowed. So some B R A. From all CRD, what are the ICs that you will get? Very fast. What are the ICs? 2 ICs you will get. Which are those? Which are those? From all we get some. So some C R D, some D R C. So I think we were clear about the ICs. Now let us find out the MC. Now read the question. All A are B. All C are D. Arre Baba. How many terms? Number of terms. You have 4 terms here, right? A, B, C, D. 4 terms. And that too, no middle term or no common term. If I say all Labradors are dogs. All Labradors are dogs. Correct? All Earth are planets. All Earth are planets. All Labradors are dogs. All Earth are planet. What is the conclusion? How will you combine these 2 statements? There is no middle term to connect the other two terms. So first rule of syllogism actually says that in 2 statements there must be 3 and only 3 distinct different terms. All right? And to know this in short, rule 1, 3 terms. Rule 1, 3 terms. Obviously, when I say 3 terms, that means 3 different terms. Okay? So rule 1, 3 terms. Let us look at this example to derive or to understand rule 2. Some ARB, some BRC. All right, immediately tell me your IC. Some ARB. Tell me. Some BRA because interchange is allowed in case of some. So some BRC. Type some BRC. What will be the IC? What will be the IC? Saurabh, there is no A equal to B now. All right, you have been told how you are supposed to write the statements. Absolutely yes. Some BRC interchange. So some C R Now you have to find out main conclusion. And see, B here is the middle term. So main conclusion will be formed between A and C. Okay, what will be your main conclusion? Srihari, how did you get that? Bhavan, Shreyank, Aarti, Saloni, Rajneesh. अरे बाप रे बाप. Everybody is giving me an incorrect answer. Why? Because, as is evident, you people have told me that you love rhythm. So what is going on in your mind is all A are B, all B are C, B gone, all A are C. Similarly, some A are B, some B are C, B gone, some A are C. When did I teach you this method, by the way? I told you till we have discussed the seventh rule of syllogism, we are going to solve all the questions through Venn diagrams. What kind of method are you coming up with, sir? It is all jugaad that you're doing, officer. This is what you will do when you will become a district magistrate or an SP. What? Draw Venn diagrams. Some A are B, some B are C, some A are B, some B are C. Do you see any connection between A and C? No intersection, sir. How much is the intersection? Tell me. 0%. And the second diagram you have to draw. Some A are B, some B are C. How much is the intersection here? 100%. What did I tell you? Least intersection and maximum intersection. You have to draw two Venn diagrams. You are not even drawing Venn diagrams and coming out with something or the other. So, sir, here, can you say some ARC? No, you cannot. Can you say some CRA? No, you cannot. No intersection. And as it is, both are positive. Can you say all ARC? Wrong, no? So, all ARC, all CRA, both are wrong. Some ARC, some CRA, both are wrong in this diagram. So, hence, Megha, if the conclusion exists, the conclusion obtained, whichever conclusion that we are getting is positive. If we are not getting a conclusion, no conclusion. MC is main conclusion. Sanskar, where were you when I was explaining that? The least intersection, no. 0% or 1%. Maximum intersection, 99% or 100%. Yes, so some ARC, some CRA are just a possibility, not a conclusion. Absolutely. Anjali, oh, everyone. Oh, listen. What are you doing? If two statements are positive, then conclusion obtained means if we are getting a conclusion, that should be positive. If we are not getting a conclusion, then no conclusion. But if we are getting a conclusion, that conclusion has to be positive. But if we are not getting a conclusion, then no conclusion. All right, listen now. Listen. So what do you see here? You see quantifier sum. You see quantifier sum. Okay. So now the second rule of syllogism actually states that if both the statements are particulars, then no conclusion can be obtained. What is particular? The sum statement. And sum not. Sum not also has sum in it. Okay. So simple as that, sir. Two sums, no conclusion. Over. So here you have a sum statement, here you have a sum statement, no conclusion. Over. No need for Venn diagrams. So it means sum and sum. Sum and sum not. Some not and some not has no conclusion. Because what do you have? You see two sums every time. Two sum, no conclusion. Sum, no conclusion. So here you can say sum and sum, no conclusion. Now, this will provide you ease of not drawing a Venn diagram also. So you will not commit a mistake. So now if I give you two statements, let us say sum A or B, sum A or sum B, sum B are not C. So what is your conclusion? No conclusion. The moment you see two sums, no conclusion. No main conclusion. IC will definitely come. No, IC we are getting from one statement only. No, some ARB, so some BRA, some CRB, some BRC, so some CRB. From one statement you are getting IC, so not an issue. But main conclusion you cannot get. Why? Because two sums give you no conclusion. Is this clear? No, Megha, in exam you could be asked IC also. That is why I told you in the beginning, both are conclusions, both can be asked. Both are present. So wait for some time. When we will solve the questions, you will know better. Okay. All right. No A is B, no B is C. Now, first things first, IC. I want IC. No A is B. Interchange. Interchange. So what will we get? No B is A. Correct? From no, we get some not. From no, we get some not. So if no A is B, then some A are not B. And as some not is being derived from no, it is being pulled out of no. So some B are not A. Interchange is allowed here. Now you tell me, for no B is C, what will be the immediate conclusions? What would be the ICs? For no B is C, what will be the ICs? Write down all the ICs. Why are you giving me only one IC? Okay, interchange will happen. Okay, so no C is B. Then after that, yes, correct, Deepika. All right, so some B are not C, which means some C are not B. So there are 6 ICs. Any of these could be given to you amongst the conclusions. So mark ICs as an answer. If any of these 6 is given to you amongst the conclusions, list of conclusions, mark that conclusion as your answer. Okay. Now let us find out the main conclusion. So do we have a middle term? Yes, middle term is there. So you have to form a relation between A and C. Can we get a conclusion, conclusive, definite kind of a thing? What is the conclusion? Tell me. Okay, very good. Aha, Shreyank. I've got a goat, Bakra. Roshan, another one. Nancy, another one. Purva, another one. Aarti, another one. Samay Bilbisi. Wow. No. कितनी गलत कर दी है तुम लोग. There is no conclusion, sir. What are you talking? Just now I told you, no. Two negatives, no conclusion. What, right? Now you will say, sir, there is a conclusion, no? If you draw Venn diagram, how? How? HOWWWW. How? HOWWWW. Sir, this is a diagram, sir. No A is B. No B is C. So, intersection here is 0%. No A is C, sir. Correct. But why did I tell you least intersection, maximum intersection? You have to draw two Venn diagrams. So here you have taken 0% intersection between A and C. How about this diagram, sir? No A is B. No B is C. So here between A and C, the intersection is 100%. I told you least intersection, maximum intersection. Okay. So we can't have any conclusive statement working as a conclusion here. You can't. So no conclusions are. What are you talking? BH80 BHAT. Rule 3, we discussed already. Two negatives, no conclusion. Both tires punctured. You can't drive the bike. Can't move it also. Especially if it is a bullet. Huh? You can't even move it. Got it? Did you get this, Shank? Okay. Move ahead to rule 4. From here, okay, let me just get this to you. Two negatives, no conclusion means if you have a no statement and a some not statement. Why some not first? If you have two no statements, or if you have a no and a some not statement, if you have a some not and some not statement, each case, no conclusion. Got it? All right. So till now we have learned three rules. Which is rule 1? Huh? Three terms. Which is rule 2? Two sum, no conclusion. Rule 3, two negatives, no conclusion. And we are supposed to learn 7 rules. 3 we are already done. 4th and 5th also very simple ones. All ARB, some ARC. What is the conclusion? First, tell me the IC. All ARB. What are the ICs? Very fast, please type. Correct, Anjali. Vedshri, I have very clearly told, now this is the nth time I am saying, whether IC is given or MC is given, both are conclusions. That is why I am calling them immediate conclusion and main conclusion. Both are conclusions. Whichever is given to you in the list of conclusions, mark that as the answer. Be it IC, be it MC. Both are conclusions. Equal weightage. All right, sir. So all ARB, some A R B interchange, some B R A, some ARC interchange, some CRA. So these are, let us say, 3 ICs. Okay. Now MC. Venn diagram. बांट रहे all ARB. So 2 diagrams for all ARB. All ARB. All ARB. Correct. Then some ARC. Some ARC least intersection between A and C I'm taking. Some A RC. Okay. Some ARC. Done? Okay. Now, A here is the middle term. So this time you want a conclusion between B and C. You want a conclusion between B and C. Now, first things first, this is positive, this is positive. So your conclusion will be either in terms of all or in terms of some, because these two are positives. From two positive statements, if we are getting a conclusion, that conclusion must be positive only. From two positives, if we get a conclusion. If we are not getting a conclusion, no conclusion. But if we get a conclusion, that has to be positive. And between whom? B and C. Can I say all B or C? Not here in this diagram. But definitely I can say that some B or C. For sure. Here also some BRC. So we should get some BRC. Interchange some CRB. Okay, sir? All right. Now the rule. I will show you the rule. Now what is this given to you? sum statement. True? All right. So if one of the statements is sum, then what is your conclusion here? What is the conclusion you're getting here? Sum. One statement sum, conclusion also 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 sum. That is exactly what we are talking about. One sum, conclusion sum. That is, one statement is sum. It consists of some word. Then conclusion will also start with sum. Over. So don't waste your time over Venn diagram here in this case. Now onwards. But you should know Venn diagrams. That's how it is. So it means what? If I have two statements, let us say if I have two statements, one starting with all and the other starting with sum. Conclusion will be sum. Okay. If I have a statement, I have two statements, one starting with all and the other starting with sum not, then the conclusion has to be sum not. If I have two statements, one starting with sum and the other starting with no, these two quantifiers, then sum and no in English language also, you know it is sum not. So as you can see, one statement sum, conclusion sum. One statement sum, conclusion sum. One statement sum, conclusion sum. Get it? Now the rule 5 actually we already know. But then fine, let me check. ICs, you please tell me, all ARB. Very fast you type down. Very fast. Come on, guys. Hurry up. Hurry up, pa. Yes. So what is that? Sum A are B. Then obviously sum B are A. No B is C. First you reverse this. No C is B. From no, we get sum not. Alright? So then you have sum B are not C. Sum C are not B. So 2 ICs here and 3 ICs here, total 5 ICs you have. Any of these given to you or included amongst the list of conclusions, please mark that as the answer. Now, main conclusion. What is the middle term? Remove the middle term first because the conclusion has to be between A and C. Okay. So all A are B. Two standard diagrams. All A are B. No B is C. That means B and C are two disjoint sets. Okay, all A are B, A are included in B, and no B is C. So hence, no A is C. All Labrador are dogs. No dog is cat. So no Labrador is dog. No Labrador is cat. Simple. So here what do we get? We get no A is C. But then it also means no C is A. Also from no, we get some not. So some A are not C. Interchange because some not here is being pulled out of no. All right, some C are not A. So you get 4 MCs here. Get it? Now, what is it that we must notice? See, this is a negative statement, and your conclusion also everywhere is negative. You remember? You remember? What is this? This is positive. This is negative. So your conclusion will also be negative. Remember? 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 One statement positive, one statement negative. So your conclusion, if at all we are getting a conclusion, we are getting a conclusion, no? So that must be negative. Bike, one tire punctured, negative. One tire inflated with air, positive. So you are trying to somehow ride that bike. What will be your experience? Negative. Okay. So this we have already discussed. So one statement negative, conclusion will be negative, as we have discussed. So all and no. These are two statements given to you. So you will get no, and from no, you will get some not. If you have all and some not, these two statements, then your conclusion will also always be in terms of some not. All right? Why? One sum, conclusion sum. One negative, conclusion negative. And as it is discussed previously also, some and no gives us some not. See, one sum, conclusion sum. One negative, conclusion negative. Clear? All right, sir. So now we are at rule 5. 5 rules we have done. All right. So which are these 5 rules? Please tell me. One, three terms. Second, two sum, no conclusion. Third, two negatives, no conclusion. Fourth, one statement starts with sum, then conclusion will also be in terms of sum. Fifth, one statement is negative, so a conclusion will also be negative if the conclusion exists. Correct, sir? Okay. Now, to derive or to study rule number 6 and 7, we need a table here. And that table is called tick cross table. In actual, it is called distribution table. I have written this and I am cutting it. Why you don't need to remember the name distribution table? Sir, what is the meaning of distribution here? Array, we are not conducting research, Ray. We just simply want to remember only that much which is sufficient to solve the question well within the time limit and earn us 2.5 marks. Okay. What is this STPT? ST, scheduled time? No, obviously not. So this is what? First term, my dear. And this is the second term. Remember, subject term, predicate term. Subject term, predicate term. Now see, 4 quantifiers are given to you. All no, some not. All no, some not. And examples are shared here on the right hand side. All A are B, no A is B, some A are B, some B are not B. Now, these quantifiers are assigned tick mark and cross mark in a particular order. Okay. And you just have to memorize that order, that sequence. This table, you memorize it, apply it. With the help of this rule 6 and rule 7 will be observed. Apply these two rules, you get your answers. All right, so I'm giving you the table now, and we will just by heart this table. Now, I have not made this table. None of my contemporaries have made this table. Now, have you heard of someone called Aristotle? You've heard of someone called Galileo? You have heard of Plato? You have heard of Socrates? Who are these? These are all Greek philosophers, right? Okay, so they actually have formed these rules of syllogism, not me or anyone else. Okay, so today you're studying something which was actually made by or approved by Mr. Aristotle, one of the greatest scientists ever. Okay, so eureka. Sarji, that was Archimedes' principle, right? Anyhow, everyone now, look here. All tick cross, no, tick tick, some cross, some not cross tick. Hold on, wait. We will get acquainted with this. Arey, I made you people remember all those equations also. March, November, April, July. So wait, I'll make you memorize this also. So don't worry. Give me time. Have patience. So don't ask, sir, how is it that we are giving a tick mark to first term and cross mark to second term? Please, sir, don't do that. Please don't do that. Okay. Why? You just need to memorize this table. You're not here to, this much book of syllogism. You don't want to just mug it up. True. So simply what you have to do is remember this table. Over. Remember. Over. Let us make some observations. No. So all is starting with tick mark and no is also, see, starting with tick mark. Okay. Obviously, the second symbol here is to be used in the second way. So tick and cross, tick and tick. Okay. Now here, all and no, they give you information about each and every element. But some and some not, which are particular, they give you information only about one element or particular element. True? True or not? Okay. So that is why some and some not, they start with cross. All and some, all and no, they start with tick. Anyhow, just a way of remembering. But forget everything there. I just want you to observe one thing. No, no A is B. No A is B. Tick, tick. Now, if I interchange the seats of A and B, then what do I get? What do I get? What will I get? I'll get no B is A. And if B is asked to carry his symbol along with him, and A is asked to carry his symbol along with him, and then to interchange the positions, still the sequence, the order of tick marks will not change. No, we'll still get two ticks. Proof that in case of no, the two terms can be interchanged. All right. Now some ARB. Similarly, this is what? Cross cross. Okay. Now if A is asked to go to B's position and B is asked to go to A's position, that is interchange their seats, then we get a statement, and that is sum B are A. Still, the sequence of cross marks do not change. We still get a cross cross. Proof that in case of sum, the two terms can be interchanged. Okay. Now let's talk about opposites. Okay. So pairs of opposite quantifiers. Pairs of opposite quantifiers. See, you have one pair that is of sum and no. Sum and no. See here. What is sum? Cross cross. What is no? Tick tick. Cross is opposite of tick, no? Tick is opposite of cross. Don't say right wrong. Why can't you speak the same language as I am speaking? Why don't you call directly these as tick and cross? Why do you need to change the form? Not required, no? The second one here is all and some not. Observe. All is what? Tick cross. Some not is what? Cross tick. See? The order is just the opposite. So there are two pairs of opposite quantifiers. One is sum and no, and the other is all and sum not, right? Because their symbols, order in which the symbols are written, are opposites. Okay, that is here. If I have cross cross, then I get a tick tick here. If this is tick cross, then this becomes cross tick. So is this clear? All right, sir. It is clear. So now we have to remember this. All right, I'm writing now. I'll keep on writing now, and this is the way I want you to do it in your notebook also. So pick up your pen. Pick up your pen. Observe me doing something for 2-3 times, and then start copying the same. That is not copy from the screen. That is start copying that action. Okay. See, all tick cross, no tick tick, some cross cross, sub not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. All tick cross, no tick tick, some cross cross, some not cross tick. Got it? अब तो याद हो गया होगा. Yeah, Sejal, correct. It is AEIO method actually, but this one is more effective from the examination point of view. Got it? Lovely. Up to you, Anjali. Don't commit an error. I don't know why you cannot adopt my method. Why is it that you're getting comfortable with your method? See, your glass should be empty. Let me fill it with my knowledge that I want to impart you with, rather than you becoming an Einstein. But still, go ahead. I don't mind. So let us look at a question here. All ARB, all CRB. So first you tell me the IC. All ARB. Some ARB, some BRA, all CRB. Some BRC, some CRB. Correct? Now tell me the MC. What will be the MC? Middle term here is B. Very good, Purva. Very good, Stephen. Very good, Yashpal Singh. Very good, Janvi. Very good, Himani. Very good, Sarita. Are make the Venn diagram? No. Till now I have shown you only one method. So you people are giving me all ARC and whatnot here. Correct? All A are B. Two standard diagrams, right? All right. All C are B. What? Right? All C are B. Any intersection? Do you have any intersection between A and C? Tell me. Intersection between A and C. is 0%. See, that is the problem with Venn diagrams. You tend to forget one of the cases. Okay. So there is no intersection between A and C. How can you say some A or C? Incorrect, sir. Incorrect, sir. No A or C. How can you say that, Surya? This is positive from two positives. You can't get a negative. See, again. No, Roshan, you can't. Yes. Megha, Palak, Deepika, all correct. Sar, now see what I'm going to do. As it is, you have no conclusion here. Is it or not? Because here 0% A is C, here 100% A is C. So no conclusion. Okay. Now see here what I'm going to do. How I do it. You know that all tick cross, no, tick tick, some, cross cross, some not, cross tick. Correct? So all is what? Tick cross. This is what? Tick cross. Now observe which symbol is B getting in both the statements. In the first statement, B gets a cross mark. In the second statement also, B gets the cross mark. 5 seconds. The rule here is, listen to me carefully. Listen to me carefully. If middle term gets 2 cross marks, no conclusion. Over. See, middle term B is getting a cross mark here, 2 cross marks, cross mark in both the premise. So hence, no conclusion. Simple little star. All right, so let's have another example here. This time, let's do it fast. All A or B, some B or C. All A or B, tick cross, some B or C, cross cross. B, middle term, 2 cross marks. No conclusion. Over. The back. No main conclusion. ICs, so anyhow you will get from a single statement only. No? Easy, no? Look at this one. All A or B, tick, cross. Some B or not C. Cross, tick, middle term, 2 cross marks. No conclusion. है ना मजेदार? Magic. Get it? Now? Okay. So the sixth rule in syllogism says if middle term, empty is middle term. If middle term gets 2 cross marks, no conclusion. If middle term gets 2 cross marks, no conclusion. Now, moving on to the most important rule of syllogism. Okay. Because with this, you only come to know, with rule 6, you only come to know whether you get a conclusion or not get a conclusion. But with rule 7, you will also know what quantifier is to be used and you will get your final conclusion. So most important and easiest of all is rule 7. Okay, for that I take up this example. You already remember. All A or B, tick, cross. All B or C, tick, cross. Middle term, common term is B. Here B is getting a cross mark and here B is getting a tick mark. So is B getting 2 cross marks? No. It is getting one cross mark and one tick mark. It is not getting 2 cross marks. Had B acquired 2 cross marks, then in that case, no conclusion. We just now learned, no? If B gets 2 cross marks, no conclusion. But here, B is not getting 2 cross marks. It is getting a tick mark also. So conclusion is possible. There may be conclusion. And as it is, you see, if you remember, these were those 3 conclusions that we had obtained. Okay. Now, put tick and cross here also. All A are C, some A are C, some C are A. Get it? Now make an observation. Make an observation. What does B get? What does A get here? Tick mark. What does A get in the conclusion? Here, tick mark here, cross mark here, cross mark. That means that a term which gets a tick mark in the statement may get a tick mark or may get a cross mark in the conclusion. True? So there is no rule for them. But, notice what does C get here? C gets a cross mark. So C will definitely get a cross mark in the conclusion also everywhere. Okay, now that is your seventh rule. So seventh rule here states, let me first give it to you. A term which is crossed in a premise, premise you know is a statement, must be crossed in the conclusion. All right. And in Hindi, you can remember it as cross wale ko cross milega. 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 Crossed will be crossed. Crossed will be crossed. Crossed will be crossed. Crossed will be crossed. Cross wale ko cross milega. Cross wale ko cross milega. देखो, how simple is this now? Watch this. ICs finally, final time, all ARB. What are these? Some ARB, some BRA. No AC, 3 ICs. That is, no C is A after interchange. And from no, we get some not. So some A are not C, which means some C are not A. Now let us have a look at the main conclusion. All tick cross, no tick tick. Okay. Now, which is the middle term here? A. Is A getting 2 cross marks? No, A is not getting 2 cross marks. No, it is getting 2 tick marks. It is not getting 2 cross marks means we might get a conclusion. And the conclusion has to exist between whom? Between B and C. Conclusion has to be between B and C. Now C. What kind of a statement is this? Positive. What kind of a statement is this? Negative. So what have we learned? One negative, conclusion negative. One negative, conclusion negative. So you have to find out the MC. So MC also has to be negative. So which are the negative quantifiers we have? No and some not. Now in tick cross table, what does no get? Tick tick. And what does sub not get? Cross tick. Clear? No is tick tick and sub not is cross tick. Now see, as per the seventh rule of syllogism, cross wale ko cross milega. Crossed must be crossed. Now B is crossed here, so it must be crossed in the conclusion also. That is, B must be placed in that particular slot where there is a cross mark. Okay, compulsorily. All right, sir. So first things first, tell me, out of no and some not, which quantifier has the provision of cross slot, or cross space, or cross seat? It is sub not. So here I will have to use some not. So I will have to use some not. So what is that? Some cross are not tick, because some not is what? Cross tick. Some not is what? Cross tick. Okay. So see here. So B comes and sit here. क्योंकि क्रॉस वाले को क्रॉस मिलेगा. B is crossed here, so B should be crossed here also. And remaining C, which is getting a tick mark, has to sit here. That's it. So sum B R not C is the only conclusion that you can obtain. Because in sum not you cannot interchange the two terms also, no? There. Where is A? A is middle term, Megha. Middle term is not present in main conclusion. The main conclusion has a conclusion between the other two terms, bete. Right? Okay. That is syllogism for you. We're done with our basic rules. So look at this one. Another question for rule 7. So sum A or B. Sum is what? Cross cross. No is tick tick. No B is C. So what is the middle term here? Common term is B. First thing you check, is B getting 2 cross marks? No, it is getting 1 cross mark here. So we may get a conclusion. The second thing is this is positive and this is negative, and as it is, we know that sum and no. Remember, I had written it, sum and no in English language is also sum not. Sum and no are sum not. So your conclusion has to be in terms of sum not. So sum cross are not tick. So who's getting cross mark? Because you are supposed to form a relation between A and C. So it is A which is crossed and this is C which occupies the remaining position. So sum A are not C. You cannot interchange the two terms in sum not. Perfect, perfect. You got it. You got it. All right, sir. So a quick revision. 3 terms, 2 sum, no conclusion. 2 negatives, no conclusion. 7 rules of syllogism. 1 sum, conclusion sum. 1 negative, conclusion negative. 6th, middle term, 2 cross marks, no conclusion. A term which is crossed in a premise must be crossed in the conclusion. Crossed must be crossed. Crossed must be crossed. Cross वाले को cross मिलेगा. Cross वाले को cross मिलेगा. Correct? Apart from that, these are various combinations which I had written separately. Now if you memorize them, obviously good. But it is with practice that anyhow these combinations will be registered into your mind. But what you need to remember is positive and positive should give you a positive. Positive and negative will give you a negative. And negative and a negative means no conclusion. Alright? See, all here is positive. All is positive. So from all and all, we will get all, which is again positive. From which we get some, which is again positive. But there is a case, there is an example. I will take 15 examples now. After this, I'm taking 15 examples. And after that, I will take up the previous year question papers. All right. So whatever is left over, obviously we will do it tomorrow. Now, all and all will also give you some directly without giving you all. So this is positive and this is positive. This is also positive. All and no, this is positive, this is negative, will give us negative no, from which we can derive sum not, which is again negative. All and no, this is positive, this is negative, will directly give you a sum not. It will not give you no. Okay, that example I have already taken with you. Yeah. Where we took a decision that our answer has to be in terms of sum not because it has a cross mark and B also has a cross mark. So B has to sit on a cross seat because crossed is cross, cross wale ko cross milega. So hence we had done this earlier. Now see, all is positive and sum is also positive. You will get positive. That is all and sum gives you sum. One statement sum, conclusion sum. Remember rule number 4. All and sum not. All is positive, sum not is negative. So your conclusion is negative. See, one negative, conclusion negative. One sum, conclusion sum. Sum and no, sum not. So this is positive and this is negative. One statement sum, conclusion sum. One statement negative, conclusion negative. Okay. So don't worry, all this will be present in front of you. Don't worry. Now, which are the combinations of quantifiers where you do not get any conclusion? Sum, no conclusion. Two negatives, no conclusion. Okay. Table, you remember? All tick cross, no tick tick, sum cross cross, sum not cross tick. All right. Now we have revised very, very simple things, and this, whatever you see here, in the 15 examples that I'm going to give you, this would be present for all the questions. Okay. So you can refer to these anytime that you want to. What are these? Well, you have combinations from here to here. 7 combinations. All right. You have rule number 6, middle term cross cross. So no conclusion. We have rule number 7. The cross term must be crossed in the conclusion. Crossed must be crossed. तो क्रॉस वाले को क्रॉस मिलेगा भैया. ठीक है. चलिए जी. So let us start solving the questions. Table you already know. Everything is there in front of you. Whatever I showed you here, which is written in white, is now written in yellow. Now ICs, I trust you. You can find out yourself. Not an issue. No? All ARB, some ARB, some BRA. All BRC, some BRC, some BRA. All right. So now what is it that you need to do is main conclusion you have to find. So what do? While you have to find out the main conclusion, you immediately start with tick cross, tick cross. Middle term is B. Check whether it gets 2 cross marks. No, it gets a tick mark. So there might be a conclusion. So step number 1, check middle term should not get 2 cross marks if you want a conclusion. If middle term is getting 2 cross marks, then no conclusion. If middle term is getting at least 1 tick mark, then conclusion may be arrived at. Step number 2, look at the combination of quantifiers. All and all. What can you get? All and all. You get it as sum. True? Okay. And you can also get it in terms of all. So I can have it as all tick R cross. I wait for the man who got a cross mark, and that is C, which needs to sit at the cross marked seat. Remaining is A. So all A are C. If all A are C, then for sure some A are C, which means some C are. So these are the conclusions, main conclusions. So I hope this is clear. All right, sir. So let us do this one. All ARB, all ARC. Tick, cross, tick, cross. Middle term A getting 2 ticks, so no problem. All right. Now all and all, we can have conclusion in terms of all, or we can have the conclusion in terms of sum. Now what is the symbol for all? Tick and cross. For sum, cross cross. Now what is it that B is getting? Cross. What is it that C is getting? Cross. Cross वाले को cross मिलेगा. Which quantifier has 2 cross marks? Sum. So your answer here has to be sum B or C some C are B. Perfect, you got it. You got it. All A are B, tick, cross. All C are B, tick, cross. Middle term. Tell me, what is the conclusion? Tell रहे Perfect. So middle term gets 2 cross marks. So hence, no conclusion. Over. Okay. Tell me this one. All A are B, all C are A. Tick, cross, tick, cross. So here middle term is A. It is getting a tick mark here. Okay. Does not get 2 cross marks. So next step is observe the quantifiers. Combination. All and all. All and all. Here you are getting all only. Tick cross. Correct? So you have all tick or cross. तो भैया क्रॉस वाले को क्रॉस मिलेगा. That's it. And remaining C comes here. All C are B. So if all C are B, then obviously some C are B, which means some B are C. Over. Got this? Are you getting it? So this is much, much faster, as you can see, more accurate, and we have left Venn diagrams behind, but we must know how to solve questions through Venn diagrams, because there are some questions which can be solved only through Venn diagrams. Okay, so give me a poll here, please. If understood, give me a yes. If not, then let us know. Understood? So first you do tick cross, you find out whether middle term should not get 2 cross marks, it gets 2 cross marks, no conclusion, does not get 2 cross mark, get at least 1 tick mark. So how many were there? Can you tell me about the poll? What percent was there? No poll, is it? It vented just like that. Vented. How could it vent? Become the Marco Polo. Mark the pearl. Mark the pearl. Marco Polo. $89. All right. Okay, let's proceed. All A are B, no B is C. Tick cross. See, all is what? Tick cross. No is what? Tick tick. So middle term is not getting 2 cross marks, it is getting a tick mark here. Alright, so we may get a conclusion. So second step, all and no. All and no is no. So no A is C. See, A is getting a tick mark, C is getting a tick mark. For tick mark, there is no rule. Tick marked term can get tick mark or get cross mark also. So no A is C, no C is A. From no, we get some not. So some A are not C, some C are not A. Look at this one now. All A are B. No A is C. We have done this question, but still, I'm doing it again. A here is the middle term. Obviously, yeah, it is getting 2 tick marks. There's no question of getting 2 cross marks. So we may get a conclusion. So look at the combination. All and no. All and no is no, which is tick tick. It is some not, which is cross tick. What is B getting? Cross. So what should be our answer? Tell me. Arya. See, no. B is getting cross mark. How can you get no? See, guys, with seventh rule, directly you're getting the answer. All right, to the perfection. Okay. So some cross are not tick. Okay, so B comes here because it is getting a cross mark, and C, who's getting a tick mark here, occupies the tick mark position. So some B are not C. Period. There is no other conclusion. All right. Tell me, sir, all A are B, some B are C. What's the conclusion? There you go, sir. Middle term, two cross marks. No conclusion. You are hardly taking 5 seconds, sir. Please remember, not taking more than 5. Correct? So that's the whole point and beauty of this particular topic. This method. All A are B, some A are C, cross cross. Middle term A is getting tick mark. So all and some is sum. See, B is also getting cross and C is also getting cross. And what is sum? Cross cross. So some B are C, some C are B. Show me this. All A are B, tick cross. Some B are not C, cross tick. What's your conclusion? Fast. What is your conclusion? Job done. No conclusion because B is getting two cross marks. Middle term, two cross marks. No conclusion. All A are B, tick cross. Some C are not B. Cross tick, middle term, B, common, is getting tick mark here. No? Okay. Then second step, observe the combination. All and sum not. Now you please tell me, all and sum not gives you what? Sum not. So conclusion is some cross are not tick. So whose cross? C is cross, no? So some C. And A comes here. Over. Are perfect, you got it? Lovely. Yes, obviously, of course. You will have to revise it. Huh? All right, sir. So we have all A are B, tick cross, some A are not C, cross tick. A, safe. We can move to the second step. What is the second step? All and some not. All and some not. So once again, all and some not should give us some not. So some cross are not tick. B is getting cross mark. So some B are not C. Do you find it easy? Yes. Why not use sum for all plus all? Why should we use it? We will use it where it is required. Deep, क्या कर रहा है मेरे बच्चे? Huh? Just see here, no, first. We used it here, no? All and all. We used some. And if one of the quantifiers is negative, conclusion will be negative, no? Then all A are B, tick cross. Some C are not A, cross tick. Yes, A does not get two cross marks. Now, see the quantifier, combination. All and some not. So once again, we have all and some not. Should give us what? Some not. So some cross are not tick. Hold on. अरे रुको रे यार. B is getting a cross mark. C is also getting a cross mark. अच्छा नहीं लगता है ना ये. Doesn't look good. Some B, C are not dash. What is this? So here the seventh rule is being violated. Cross वाले को cross मिलेगा. Crossed must be crossed. So B should be crossed. C must be crossed. But then we have only one seat of cross mark and we have two persons, B and C. who are crossed. So obviously, two people cannot sit on the same seat. No, share. Thoda, bhaiya, sarak ke. Ada, ada. Can't do that, no. True. So hence, sar. Okay, correct. Some A or B. Cross, cross. No B is C. Tick, tick. Middle term. B. Get tick mark? Yes. Does not get to cross marks. Then some and no. Some and no we know is some not. So have a look here. So it must be some cross are not tick. So A is crossed, will sit here. C is ticked, so sit here. Simple. See here now. Some A or B, cross, cross. No A is C. Tick, tick. A is the middle term. Does not get cross mark here. Does not get two cross mark. So some and no. Once again, what is some and no? Some not. Some cross are not tick. Okay. So cross is received by B. So some B are not C. Over. Got it? Alrighty, sir. 15th example we will do tomorrow and that onwards. Okay. And after that, we have previous year questions. So that we will take up tomorrow, first thing in the morning. So please join at 6 o'clock because many of you are joining late. And then you say that I have joined late, so please repeat. So that I cannot do. See, we are falling behind otherwise. I'm going quite slow with you guys that ways. All right, sir. So we shall meet again tomorrow. Square trick. We already, at 9:36, 9:37. Let's catch hold of it tomorrow. All right. So goodbye. Have a nice day. Enjoy yourself. Work hard. Do good in life. Do well in life. All right. And please keep your eyes and focus on your dreams and aims and objectives. This is Kapil Datta signing off. Nawab Singh sir's channel I'm using here. So I'm not Nawab Singh. My name is Kapil Datta. Okay. And it is not a DU, it is DA. So this is Kapil Datta signing off because yesterday somebody had written, sir, you are Nawab Singh sir or Kapil Datta sir? All right. So goodbye. Take care. All the best. May God bless you.